Okay, so we're going to look at trig functions. And we already know that if we have a function that's defined and continuous at a value, that we can just use direct substitution. So let's look at that first. So we have the limit as theta approaches 2 pi over 3 of sine 3 theta over 3 theta. So what if we plug that directly in? So I'd have sine of 3 times 2 pi over 3 over 3 times 2 pi over 3. Well, that's the 3's would cancel. I'd have sine of 2 pi over 2 pi, which is, that'd be 0 over 2 pi, which is 0. What about the next one? Well, that means cosine of theta squared, really. So 2 times cosine of pi squared. Well, cosine of pi is going to be -1. So that's going to be just 2. Easy enough. But what if we have functions that are not defined at that value? So sometimes, like we had to do the rationalization, or we had to do factoring to simplify. Sometimes we run into problems with trig functions as well. So first, let's look at this one and try direct substitution. That's going to be 1 minus cosine of 0 over sine of 0 squared. That's 1, so I got 1 minus 1 over 0 squared, which, well, that's just trouble. So what can we do? Well, let's see if we can rewrite this in a better way. So let's see, we've got sine squared. Well, I know there's some things about sine squared. I know I could do something like sine squared plus cosine squared equals 1. It's Pythagorean. So if I rewrite that, that's 1 minus cosine. That might come in handy. So let's rewrite this. The limit as theta approaches 0 of 1 minus cosine theta over 1 minus cosine squared theta. Well, that's the difference of squares. So the limit as theta approaches 0 of 1 minus cosine theta, this would be 1 plus cosine theta, 1 minus cosine theta. And lo and behold, those are going to divide out. Limit as theta approaches 0 of 1 over 1 plus cosine theta. So now, when I plug in, I get 1 over 1 plus cosine of 0, of 0, equals 1 over 1 plus 1, which is 1 over 2. Let's look at a few more examples. All right, so the limit as theta approaches 3 pi over 2 of, well, that's a 3, tangent is sine over cosine, Ah, that's nice. Those divide out. The limit as theta approaches 3 pi over 2 of 3 sine theta. A lot easier to deal with. 3 times the sine of 3 pi over 2. Well, that's going to be down there at the bottom on my unit circle. That's going to be -1. Gives me a -3. Ooh, let's see if we can rewrite this one. The limit as theta approaches pi over 2. Secant is 1 over cosine. All over 4 theta. That's nice. Those cancel. Divide out. So I get 1 over 4 theta. Oh, this is so super nice because you don't even have to remember all your unit circle there. It just simplified nice and pretty. Remember, when you are working with trig functions, a lot of times just getting them down to sines and cosines helps so much. So anytime I see a tangent, I'm always going to change that to sine over cosine. And by doing so, these divide out. So now I'm left with sine in the numerator. And I still have sine in the denominator. Oh my gosh, that's so nice. That's going to divide and leave me with just a 1. And the limit of just a constant is that constant. Beautiful. Now, you know, we skip the part of just trying to substitute in to begin with and not even trying to rewrite. Now there's 2 special cases where even rewriting doesn't really help. The first one is sine of theta over theta. So this one we're going to look at a little bit differently. We're going to use our calculator to do this. So the best way to put this in the calculator is I'm going to go to my y1 and I'm going to put it in as sine of x divided by x. Now, if you have an updated operating system, you can actually type it in as a fraction. So I'll show that. We're going to go sine of x. Now if I don't do that, I can do sine of x divided by x. Alpha f1 gives me a nice fraction. And we're going to be typing in values. Now there's a couple of ways to do this as well. One way is to use your home screen. I don't know if you knew this or not. So I can go alpha f4, choose y1, and start substituting in -0.01. Oh, I noticed something I forgot to do. That's not right. Why is that not right? Well, in calculus, we're going to make sure that we are always in radians, and I was not. There we go. Now let's do y1 of, we're going to get close to 0. And it keeps going, doesn't it? We got 0.99999. Gosh. Now what about the other side? The other side of 0. That should be a song. What do you think we're getting close to? So looking at the table, if we're coming from the left, it's getting really, really, really close to 1. If I'm coming from the right, it's getting really, really, really close to 1. So overall, it's 1. But what happened if I've actually plugged in straight up? Well, I would have gotten sine of 0 over 0, which is 0 over 0, which is trouble. So it couldn't work just like that. So what about if it was sine of 3 theta over 3 theta? So I'm going to go in here, and I'm going to, if you didn't, insert 3, and then change that to a 3x. Now look, and notice if I just went to the table, I go change the setup, start at 0. Whoops. Having one of those mornings. Lovely non-graph. At 0, it gives me nothing, right? So what about, I can go back and select some of these. It again gives me 0.99999. Even if I selected negative, it again gives me 1, 1, 1. So it doesn't matter what kind of constant it is, as long as these match, we'll always get a limit approaching 1. What about 1 minus cosine theta? So I'm going to do this one a little differently, just so you can kind of see the two ways to enter this in the calculator. 1 minus cosine, and then the denominator is just going to be x. So the other way to approach this is to do the table setup with ask for the independent. This is sometimes a little bit faster because you can just type in your values. So let's see what we get on this one. So this is negative 0.005. That's negative 5 times 10 to the negative 4. So this is negative 0.1235. This one's negative 0.12345. On the positive side, 4, we get the following. So what are we approaching as we come in from the left? Well, we're getting more and more decimal places. This is getting smaller and smaller and smaller and smaller. It's approaching 0. From the right side, it's approaching 0. Overall, it goes to 0. So these two special trig functions are two that I would suggest memorizing. So this is one I would put to heart, You're probably going to see it on a lot of quizzes. So get ready for it. And when we can somehow turn something into one of these two, kind of like an identity, we want to, because it makes it so much easier. Now let's look at some examples of how to take something and turn it into one of these beautiful identities. If needed. Sometimes we don't. Sometimes they're straightforward. Like, for example, this one. We don't have the variable in the denominator. So I would immediately start by just plugging in. Well, let's see. E to the 0 is 1. Cosine of 0 is 1. So this is just 1/4. Don't make it more complicated than it needs to be. And on this next one, if I tried doing direct substitution, it's not going to work. So what could I do? Well, I'd really, really, really like that to be a 4 theta in the bottom. Then it would match my rule. So let's look at some things we can do to keep it mathematically accurate, but make this match the patterns we've seen. Well, I'd really love there to be a 4 in the bottom. So to balance, I need to put a 4 up here. And that's the same as multiplying by 1, right? Now I can move that out to the front. And now I have sine of 4 theta over 4 theta, which this matches that identity. And now we have 4 times 1, which is 4. How could we do the same thing for number 3? Well, first, I want that to be a 2x. So I'm going to move this 3, well actually that'd be a 1/3 really, out to the front. I want that to be a 2 down there. So times 2 times 2. That's going to move out there. X over 2x. Whoops. I don't know why I keep wanting to do a theta with pi right there. That matches our new pattern. So we just get 2/3. How about let's pull 2/3 out for this one. How could I change that into being one of the identities? (10/3) limit of theta as theta approaches 0 of sine of 5 theta over 5 theta. Matches the identity, so I'm left with 10/3. Do you see how there might be a shortcut for those? Maybe. But this last one here on this page doesn't match. Oh, darn it. But I do see tangent. Let's see what I can do with tangent. Whenever I see tangent, I'm going to always rewrite it. So that's really tangent times 1 over theta. So how about I write that? Tangent times 1 over theta, Well, tangent is just sine over cosine. Ooh, I see a sine, I see a theta. I'm going to rewrite that as sine over theta times 1 over cosine. And remember, when we're multiplying two functions inside, I can separate it out. Beautiful rule, because we recognize this as 1 and this as something a lot simpler. Now I can do direct substitution. Well, if I plug in 0 for theta, that's 1 times 1 over cosine 0, whoops, which is 1. So 1 over 1, which is 1. I have a few more, which you're welcome to try and then check your answers or follow along. All right, that doesn't match the pattern. What can I do? So my first thought is I see 2 with both of the items in the numerator. So let's see, what can we do? We can factor out a 2. Okay, so my first thought is I'm going to check my rules. Well, I've got a rule about 1 minus cosine over theta, but this is cosine squared. So there's 2 ways I could handle this. I could turn 1 minus cosine squared into sine squared, or I could factor it into 1 plus cosine times 1 minus cosine. Either way you do it, you will end up with the same answer. So I'm going to go with the simplest version, which is to change it to sine. I can go ahead and move that 2 out front. And so I have a sine of theta over theta times another sine of theta. Split it up. This goes to 1. So I have 2 times 1 times, go ahead and do direct substitution, sine of 0. Nice. So that's 2 times 1 times 0, which is 0. Ooh. Next one's interesting. Okay, so let's think. Could I separate it into 2 fractions? Sure I can. That would be 1 minus cosine theta over theta plus sine of 2 theta over theta. And now, using my rules of limits, separate it into 2 limits. Okay, so the first one I do recognize. That one is going to go to 0. The second one is almost there. One thing. I want the denominator to have a 2. So I need to put the 2 there, which actually can move to here. Now this becomes a 1. And now we just have a 2. Ooh, cosecants. Oh, cosecant is just, let's see how we could do this. First, let's do something interesting and maybe split it up. Then this is gonna, if I'm not careful, this could get really complicated. So let's make it simple. Well, that's nice. That just turns into a 1. Cosecant is like 1 over sine. So that's really sine over theta, which if I split these up, that matches our rule. And so this is a 1, this is a 1, and we just get 2. Ooh, let's see. First thing, I see that both have a sign. Let's factor out a sign from each of the terms in the numerator. Ooh, that's really x times x. So really, that's sine x over x times 1 minus cosine x over x. Nice. Properties of limits. Can split this up. And each of these match a special pattern. This one's a 1, this one's a 0. So overall, the limit is 0.